to this lesson. I'm teacher Agnes, and today we are going to be discussing about algebraic fractions. So in the previous lesson, we discussed about algebraic expressions. Now we are going to focus on algebraic fractions. So these are fractions that either the numerator or the denominator is made up by an algebraic expression. So we know the normal fractions such as a half, maybe plus a quarter. Now these are the normal fractions, but an algebraic fraction is like x over 2. That's an algebraic fraction because the numerator is an expression. Then another one like x plus 2 over 3. That is also an algebraic fraction. And maybe 4 over 2x. So here the denominator is an expression, and therefore this fraction is an algebraic fraction. Now algebraic fractions can be added or subtracted. But before we add them, I want us to remind ourselves how we add the normal fractions, because we are going to borrow the knowledge from there. So if you have a half plus 1 over 4, this would be equal to, the LCM of 2 and 4 is 4. Then we'll do 2 divided by 4 divided by 2, which is 2, times 1, which is 2, plus 4 divided by 4 is 1, times 1, which is 1. And this would be equal to 3 over 4. So that is how we add normal fractions. So how then do we add algebraic fractions? So we follow the same procedure. So in this case, let's say we have two fractions like x plus 2 over 3 plus x minus 2 over 4. So just like we have done with the normal fractions, so we are going to begin by getting the LCM of 3 and 4, which is equal to 12. Then the same thing we do, here we did 4 divided by 2, which is 2, then 2 times 1. So we'll do 12 divided by 3, which is 4, then 4 times x plus 2. So 4 times x plus 2. Then 12 divided by 4 is 3, then 3 times x minus 2. So plus 3x minus 2. So now when you open the brackets, we will have 4 times x, which is 4x, 4 times 2, which is 8, 3 times x, which is 3x, 3 times negative 2, which is negative 6. All that divided by 12. So at this point now, we are going to simplify the numerator by putting the like terms together. So we have 4x and 3x being like terms. Then we have 8 and negative 6 being like terms. So this will be 4x plus 3x, then plus 8 minus 6, all that over 12. And this will be equal to 4x plus 3x, we have 7x, then 8 minus 6 is 2, all that over 12. And that will be the final answer. Now this question can be asked as, express this as a single fraction, because you realize that after adding the two, we are ending up with a single fraction. So that is how you do it. Let us look at another example. Now in this example, we are going to look at algebraic fractions that are being subtracted. So express x plus 2 over 3 minus x minus 2 over 5 as a single fraction. As a single fraction. Now for us to do this, we will have to subtract the two fractions. And for us to subtract them, we are going to begin by getting the LCM of the denominators. So we have 3 and 5. The LCM of 3 and 5 is 15. So we have 15 divided by 3, which is 5. Then into brackets, x plus 2. Then 15 divided by 5, which is negative 3, into brackets, x minus 2. Alright? So now, we are going to open the brackets of the numerator. 5 times x is 5x. 5 times 2 is 10. Negative 3 times x is negative 3x. Then negative 3 times negative 2 is positive 6. All these divided by 15. So then we are going now to bring the like terms together. So this will be equal to 5x minus 3x plus 10 plus 6. All that over 15. And this will be equal to 5x minus 3x is 2x. Then 10 plus 6 is 16. All that over 15. And this will be our final answer. Now, I need you to be very careful with this type of a question, especially when it comes to the multiplication here. Because negative times negative gives you positive. Do not forget about that. So now we are going to look at algebraic fractions that have letters in the denominators. How do we go about that? Now, in this example 3, we are going to express r plus t over r minus r minus t over t as a single fraction. So the format is the same. We are going to begin by getting the LCM of r and t. Now, since r and t are not similar, the LCM will be the product of the two. So this will be equal to the LCM of r and t is RT. So now we are going to follow the same format. RT divided by R is T. Then we multiply by R plus T. And then RT divided by T, we get R. Remember this negative, so it's going to be negative R. Then we multiply by R minus T. So at this point now, we are going to open the brackets. T times R will be equal to TR. T times T will be equal to T squared. Negative R times R will be negative R squared. Then negative times negative is positive. So negative R times T is positive RT. Do we have any like terms here? So do not forget to divide by RT. So TR is basically RT. So RT and RT are common. So if we add them, we will have 2 RT plus T squared minus R squared, all that over RT. And that is how you work out algebraic fractions that have letters as the denominators. Now we are going to look at one more example where we have one denominator being a letter or made up of letters and another denominator made up of numbers. Now in this example, we are going to express 4x minus 2y over x plus 3y over 4 as a single fraction. So you notice that in this case, in the denominators, in the first denominator we have a letter, and in the second one we have a number. So the format is the same. We are going to start by getting the LCM of the two, which is x times 4, which is 4x. Okay? 4x is the denominator. So now we divide. 4x divided by x, the x will cancel, we remain with 4. Then we multiply by 4x minus 2y plus 4x divided by 4, the 4's will cancel out, then we remain with x. So we multiply by x plus 3y. So next we open the brackets. So now we have 4 times 4x, which is 16x. 4 times negative 2y, which is negative 8y, plus x times x, which is x squared, plus x times 3y, which is 3xy. All that over 4x. Now looking at this question, do we have any like terms? So here we have x, here we have y, here we have x squared, and here we have xy. So there are no like terms. Therefore, we cannot go further than that. And that will be the expression of this as a single fraction. So next we are going to look at, in some cases where you have one single fraction that has a whole expression like this one in the numerator and another expression in the denominator, how do you simplify them? Now we are going to look at how we can simplify fractions through factorization. So to begin with, we are going to start with AB plus AC, all that over BX plus CX. So when you look at this is an algebraic fraction. We have a numerator and a denominator. Now for us to simplify this fraction, we will need to factorize it first. So we are going to start with the numerator. So the numerator here is equal to AB plus AX. So looking at AB and AC, do we have any letter that is common? We have A, which is common. So if you factor A out, we will have B plus C. Then looking at the denominator, we have BX plus CX. Do we have a letter that is common? X is common. So if we factor X out, we will have B plus C. Now since we have factored both the numerator and the denominator, we are now going to combine them as they were initially in the question. So we will have A into brackets B plus C, all that over X into brackets B plus C. Now since the two factors are the same, they will cancel out and our final answer will be equal to A over X. And that is how you simplify by factorizing first. Let us look at another example. So in this example 2, we have AM minus AN plus BM minus BN, all that over A plus B. So in this case, like you can see, the numerator needs some factorization, but the denominator is okay. There is no way you can factorize it further. So the numerator, which is AM minus AN plus BN minus BM minus BN, we are going to take a pair. Look at what is common. Now A is common, so we factor it out so that we have M minus N. Then here we have BM minus BN, so we factor out B so that we have M minus N. Now M minus N is a common factor, so we will have M minus N, and then we multiply by the two multipliers, A plus B. So now we have fully factorized the numerator. We can now combine it with the denominator. So we will have M minus N into A plus B over A plus B. So like you can see, we have a common factor. A plus B and A plus B is common. So we can cancel A plus B by A plus B, and then we will be left with m minus n, and that will be the simplified version of this question. So we are going to look at another example that has a different format. Now in this last example, we have ax, okay, minus 2a plus cx minus 2c, all that over 6a plus 2ax, then plus 6c plus 2cx. So again, we are going to separate the numerator from the denominator. So our numerator is ax minus 2a plus cx minus 2c. So looking at these two, we are going to factor out a. So factoring out a, we have x minus 2, then plus c into, so here we have cx and 2c, and c is common. So we factor out c, and then we'll have x minus 2. Now since these two are the same, we will combine into 1, then multiply by the multipliers a plus c. So we have factorized the numerator. Now we are going to factorize the denominator. So in the denominator we have 6a plus 2ax plus 6c plus 2cx. So looking at these two, between 6 and 2, they are both divisible by 2, so 2 is common. Then a is also common. So we will have 6 divided by 2 is 3. Since the a is already outside the bracket, we won't have it inside the bracket. Then plus 2a is outside the bracket, so here we have x. Then plus, between these two, 2 is common, and then c is also common. So 6 divided by 2 is 3. Plus, since 2c is outside the bracket, we will have x alone. So now 3 plus x is a common factor. So it is being multiplied by 2a plus 2c. 2a plus 2c multiplied by 3 plus x. Now if you look at this, you notice that we can factorize this further because 2 is common. So this will be 2 into a plus c, then 3 plus x. Now since we have factorized both the numerator and the denominator, we are now going to put them back together and divide them. So the numerator is x minus 2, then a plus c. So all this over the denominator, which is 2 into a plus c, then times 3 plus x. Do you find anything that is common? A plus c is common, so this and this will cancel out, and then we'll be left with x minus 2 over 2 into x into 3 plus x. So that is how you simplify fractions through factorization. So if you come across a question like this that asks you to simplify, for you to simplify it, you have to first factorize it. And remember, to factorize is to put brackets. Then in the end, you cancel out the factors that are common, and then you'll have your final answer. Now the next subtopic that you're going to look at is substitution. How do we substitute values in an algebraic expression? So what is to substitute? To substitute is to use one thing in place of another. You can substitute meat with vegetables. You know, if you're taking ugali and there's no meat, you can decide to use vegetables. So you substitute, vegetables with meat, or the other way around. Or you can substitute coffee with tea. So when it comes to math, when we talk about substitution, we mean that where you have letters, you can substitute those letters with numbers, all right? Substituting letters with numbers. For instance, given that A is equal to 5, B is equal to -2, and C is equal to 3, find the value of AB squared minus C, all that over 4AC. So we are going to determine the value of AB squared minus C over 4AC. So we know that A is equal to 5. So where there is A, we substitute with 5. Where there is B, we substitute with -2. Where there is C, we substitute with 3. So now our expression will be A is 5 times B squared -2 squared minus C, which is 3, all that over 4 times A, which is 5, times C, which is 3. Okay? So now we have substituted the values in the algebraic expression. Next, we are going to evaluate. We are going to work out this and come up with one answer. So this is equal to -2 squared is equal to 4. So 5 times 4 is 20, then minus 3 over 4 times 5 is 20. 20 times 3 is 60. So now 20 minus 3 is 17 over 60. So we have substituted and then evaluated, and our final answer is 17 over 60. Let us look at another example. In this question, we are going to determine the value of AB squared minus AC squared plus BC over AB plus CB, given that the values of A are 5, B is -2, and C is 3. So we are going to substitute these values in each of these letters. So A is 5. So we will have 5. We multiply by B squared, so -2 squared, minus A squared. A is 5, so 5 squared, multiplied by C, which is 3, plus B. B is -2, multiplied by C, which is 3. So all we are doing right now is substituting. Then next, A is 5, multiplied by B, which is -2, plus C, which is 3, times B, which is -2. So now we are going to evaluate. Here we have -2 squared, which is equal to 4. 4 times 5 is 20, minus 5 squared is 25. 25 times 3 is 75, plus -2 times 3 is -6. All that over 5 times -2, which is -10, plus 3 times -2, which is -6. Now we are going to add and subtract what is in the numerator. So 20 minus 75 is -55. When you have plus and negative, they become a negative. So -55 minus 6, which is -61, over -10 plus -6 is -16. Now at this point, the two negatives will cancel out, and now we have 61 over 16. Now you can choose to write this as a mixed number, alright? So 61 over 16 will be equal to 4, and then 13 over 16. And that is how you substitute and then evaluate. Now we are going to look at, having learned what we have learned about algebraic expressions, which are these questions that require us to apply this knowledge. So we are going to look at application questions on algebraic expressions. Now, to begin with, we are going to look at some application questions that require the knowledge of algebraic expressions. So the first one, here we have a rectangle, and the length of the rectangle is A plus B. Then the length of the width is C plus D. And the question is, what is the area of this rectangle? What is the area of this rectangle? So we know that area of a rectangle is given by length times width. The length is A plus B. This is the length. Then we multiply by the width, which is C plus D. So when it comes to multiplying them, we must open the brackets. So since A plus B is multiplying both C plus D, we will have A into brackets C plus D, then plus B multiplied by C plus D. So you see, this question is testing the knowledge of expansion. Are you able to expand? Are you able to remove brackets from algebraic expressions? So this will be equal to A times C, which is AC, plus A times D, which is AD, plus B times C, which is BC, plus B times D, which is BD. So now looking at these terms, you realize that none of them is common. So this will be the area of our rectangle. What if we needed the perimeter? Okay, if we needed the perimeter, we know that for us to obtain the perimeter, we must add all the sides. So to start with this length, we have A plus B. Then we have this width, which is C plus D. Then we have this length, which is A plus B. Then we have this width, which is also equal to C plus D. So adding this, we are going to identify the like terms. So we have A plus A, which is equal to 2A. Then B, we have B plus B, which is equal to 2B. Then we have C plus C, which is equal to 2C. Then we have D times D, which is equal to 2D. And this gives us the perimeter of this rectangle. Let us look at another different type of an application question. Now, these are other questions that we are going to look at. The first one is, a train travels at a speed of v plus 5 kilometers per hour. What distance does it cover in 2t minus 4 hours? So here we have the speed and then we have the time taken. What we want is distance. So we know that distance is equal to speed times time. So our speed is v plus 5. Then we multiply by time, which is 2t minus 4. So you need to remember this formula first, that distance is equal to speed times time. The speed given is v plus 5 and the time is 2t minus 4 hours. So when we multiply the two, the expression that we are going to obtain will be the expression representing the distance covered. So to open the brackets, we begin by multiplying v by 2t minus 4, then plus 5 multiplied by 2t minus 4. So our distance will be equal to v times 2t will be equal to 2 tv, then v times negative 4 will be negative 4v. Then plus 5 times 2t will be 10t. Then 5 times negative 4 will be negative 20. So looking at these terms, we do not have any terms that are common. So this is going to be the expression of these terms. And because we are dealing with kilometers, the units will be kilometers. Let us look at this other example. In this example we are required to determine the sum of a third of x plus y. A third of x plus y. So sum means that we add. And a quarter of x minus y. So when you look at this question, we are forming two fractions, because if you multiply this, it should be x plus y over 3 plus x minus y over 4. So for us to get the sum, we have to first determine the LCM of the denominator, which is equal to 12. So 12 divided by 3 is 4. 4 will multiply by x plus y. 12 divided by 4 is 3. Then we multiply by x minus y. So this will be equal to 4 times x is 4x. 4 times y is 4y. 3 times x is 3x. And then 3 times negative y is negative 3y. All that over 12. So now we are going to add the like terms together. 4x plus 3x is 7x. Then 4y minus 3y will be y. All that divided by 12. So this will be the final single fraction as a result of adding a third of x plus y and a quarter of x minus y. So now I'm going to give you practice questions that you will use to test whether you have understood what we have learned in this lesson. So now, learners, for your exercise, you will attempt these 3 questions. The first one, express y plus 2 over 4 minus 4y plus 3 over 5 as a single fraction. Number 2, factorize and simplify axm minus 4ax all that over m squared minus mn plus 4m minus 4n. Then given that x is equal to negative 1 and y is equal to 2, find the value of x squared plus y squared over xy. So please pay attention to the words that are giving you the instructions. Express this as a single fraction. That should guide you. Factorize, then simplify. Then find the value of this given that these numbers represent these specific letters. So I want to believe that you have learned a lot in this lesson. Thank you so much for being in this lesson. See you in the next lesson.